So I hope you can hear me. Actually, everyone gets bored of hearing me, but hopefully you can hear me well. And yeah, thanks for being here. I know it's been a long day. The talks have been great so far. So yeah, please bear a little bit longer with me. This will be as fast as I can. So as he said, my name is Walter Zimerman. I currently work as a senior SE at Amazon. I like tech in general. For the last 17 years, I've been designing, building, breaking, maintaining, building again, and designing again systems related to automation, right? Like I don't know if I would call all of them automation frameworks, and we'll see why. And I work for small companies, medium-sized companies, and big companies. So the views in these talks are actually mine. I'm not representing any of these customers, right? Yeah, so quick story. There was a couple of years ago, was working for this company. We get about 30 millisecond delay on a service, and that caused a queue to overflow, right? And we lost roughly $30 million in about 10 minutes, give it or take. Right, and the next Monday, while everyone was crying, trying to identify, and we were doing the post-mortem on the event and what happened and how do we prevent it again, as I was running the quality system, I couldn't get my mind out of this idea of how do I prevent this from happening again on my side, right? As a QAE, right, or as a member of the person maintaining a framework, how do I prevent, right? And I realized something that now sounds very simple to me, but at the moment I didn't know, right? Automated testing must cover more than just functional tests, right? It needs to do it easily. It needs to be very easy to do. It needs to do it fast. We cannot be waiting weeks to release automation, and you need to do it well. And to build a system like that is not easy, and it's not straightforward. So I guess this talk that you are going to hear today is essentially the talk I wish I heard earlier back in the days. Also, we're going to go very fast. Sorry about it. I think that I'm trying to condense 17 years of experience into only 30 minutes. I went through some of this content in pretty much full-day workshop. So what are we going to see today? We'll start with some definitions because I like common understanding and language. So we'll take a look at distributed systems, what they are, why they fail in particular ways. We'll cover testing, test automation, and testing frameworks, so that we are talking about the same thing. And then I'll discuss how do I see the architecture of scalable testing frameworks. Yeah, we're going to go, as I said, very, very fast. There will be 15 minutes toward the end, if I can, for questions, right, at the end. So let's see if we can make it. Distributed system, right? It's essentially a collection of autonomous computed components that cooperate over a network to represent a single coherent experience to the user. Well, what characteristics they have? Each component owns its own state, right? It also executes concurrently and can fail on its own schedule, but there's more. Why? Because we're in a network, right? And I'm kind of using it in a broad sense here as connected components, but there's things like latency, jitter, packet loss partition, and you also need to deal with congestion control, right? So in these scenarios, correctness of your service doesn't depend only on the internal logic. Right now, you're dealing with messages, the integrity of the messages, how they arrive, when they come, when they don't come, and it's essentially all about interactions, right? So testing must treat communication as a first-class citizen. Not only that, but the connections between these components, right? As I say in there, right, we need to guarantee that the whole exceeds the sum of its part, right? It works, yes, but now it doesn't work over there. Right? Sounds familiar? And I know the definitions are abstract and today, but think about it, right? You have your single application, just one REST endpoint. Well, that's distributed, right? And then you have a monolithic cloud-based, like, I'm not using any services. That's not true because you're using cloud storage. That is distributed. What about a voice assistant, right? That is calling speech recognition, and then you have natural language understanding, and you're changing a bunch of skills. Well, yeah, you get it correctly, or maybe not, but that's also distributed, right? So in 2025, today, pretty much every system, if not every system, is distributed, whether we did it by intention, hopefully, or by accident. Both have happened, and both are seen. Why does this matter for testing? Because boundaries multiply faster than code, right? You are now dealing with additional services that are adding API calls, there's timeouts, right? There's retries, there's new latency. And suddenly, when you start, there's things like shared secrets, permission, and once you start combining all these with the possible call paths, essentially that exceeds what a human can remember without the assistance of tools. So I think that automated scaling scalability today, it's not necessarily about throughput, running 10,000s of test cases for whatever crazy reason if you decide to do that, right? But it's also about cognitive offloading. How can we have to keep less in our head, right, and still know that we are moving forward confidently. The good thing is that if we do things correctly, the whole idea of an architecture being distributed can actually work in our favor because we can do things like swapping dependencies, injecting mocks. There's a couple of things that we can do, and hopefully we'll see some of them. So a test framework that understands messages, latency, test orchestration, or component orchestration, and assist you can actually turn all this into an advantage. I think that a service today, or some automation technology that doesn't consider these things, is ultimately deemed to fail in one way or another. So for the rest of this talk, the mental model should be, or kind of my thesis or idea is, we embrace this distributed reality, we treat every boundary as an opportunity, and we design a framework so that adding new components to your system and to your framework can take only days instead of weeks, right? And this includes full test coverage, right? Or at least some test coverage, right? Like, we're not going to include full test coverage. We'll see that later, probably. But what is testing? Everyone has been talking about testing today here, and I was kind of like, oh, do we all think the same thing? I don't think so, but I've chosen the most standard or accepted definition that I could find, which is that testing is a process of evaluating a system or component to determine whether it meets specific requirements and to identify defects, right? There's two implications out of this. First, testing is an activity. It's not a tool. And second, right, requirements drive the evaluation, and I've seen this before. If you don't have an oracle to tell you if your test case has passed or failed in some shape or another, right, you just have a description of behavior. What the definition does not mention, it doesn't mention who does the activity. It doesn't mention what language they use or what language they should use, and it doesn't mention if we are going to be clicking, sending HTTP request, or interacting with custom IoT protocols, whatever these are. Why? Because at the end of the day, testing, if I have to summarize it, is information gathering in the service of decisions, right? Everything else, like all these things that you see in there, it's essentially just technique, right? How are we going to achieve it? Definition of test automation was a little bit harder, not only to find, but also to come up with one idea that I liked. And to me, it's the use of software to perform or support testing activities, right? I don't think it's magic, and you probably should not either. It's also not a silver bullet. It's essentially a power tool for testers, right? It should amplify our reach and our repetitivity in the same way an hydraulic press is amplifying human strength. But that's all it is. Often, when you hear, and it's interesting, I've been speaking with some people, and what I hear a lot is we essentially discuss this as something that can invoke code, collect the results, and then you are posting badges in pipelines or not. I think that is more related today. My thoughts are like, that's a test harness. I wouldn't call that a test framework as it is today. It's important, right? It's very vital, but yeah, it's essentially, as I'm saying there, right? It's execution and reporting. And again, it's vital, and there are really, really good execution harnesses. And they do have some characteristics, right? They are deterministic, so they're good. They can tell you with the same data and the same system, same results. Good to go, right? They're observable. You can understand what's going on. You can parallelize things so that you can run things faster, and then they also provide useful reporting. And these are great. But they're missing many things, which I think leads to a simple conclusion, right? A test framework has to be something bigger, just because there's things missing. So framework has to be something bigger. And what I like is to think about it as an ecosystem that orchestrates people, processes, code, and infrastructure so that quality can flow continuously, right? It's this idea that I don't have to have stops or whatever. Yeah, so that would be the overall idea. 3 overarching thoughts that I couldn't place anywhere else when I'm thinking, and this has been evolving for maybe 12 years as a talk, and I've given it in different ways. Frameworks must bake in scalability as a first principle, and scalability in every sense. You should be able to very quickly expand the capabilities of your framework, and also this means that if you are going to be doubling the number of test cases, hopefully you are not doubling the time of your execution, right? And it's a first-class principle. Second, they are going, if you are doing your job correctly, they are going to encode opinions, right? Common language that is going to be shared across the team, how you are going to be tagging your features or managing them, right? The way you promote assertions, all that gets encoded in there. And lastly, yeah, this is crazy how hard it is for some people to understand frameworks are product on their own right? They are going to have some form of roadmap. You are going to have backlog groomings at certain points. You're going to have priorities, and you know what? You're probably going to need good documentation, good onboarding guidelines, good anti-patterns that you don't want your users to do or not. Right? It is a product on full ride. So how do I think about it? I think about it as 6 cooperating components. So no single site actually delivers value in isolation. But I think about this: the testware management, the domain-specific language, the resource management, the reporting, the orchestration, and the system under test. When I started this presentation, again, 12 years ago, I used to call it my 3-leg table. It was a triangle, and I've been adding more triangles to my triangle over the last few years. So yeah, let's go fast. My thoughts here is try to understand what you have, what you don't have, right? And some of these might be lying inside your current system, even if you don't see them as such, right? Testware management. This is I'll speed up because I'm running out of time. It's a library that stores every artifact your framework consumes. Yes, every artifact. DSL scenarios, there. Data fixtures, there. Mock definitions, there. Screenshots, there. Reporting templates, everything. And you know what? Everything should be treated as code, right? What that means is that because it's treated as code, each item lives in version control. You can go back and forth. You can do code reviews, right, or some form of review. So essentially, you get some form of approval and quality process in there. And a good idea here is to add semantic tags, right? There's a quick example there of some random semantic tags I came with. Why? Because you would want at some point the capability for your orchestrator to slice this library and pick the artifacts it's needed. It's going to make your life easier. More things. A good idea is to have a governing schema with mandatory properties, right? So prevent things from coming in there. You're kind of guaranteeing already the quality of the quality if you do that. Things like owner, time to run, a couple of things. Include, if you can, rot prevention policies. That was brought up earlier in another of the talks. If you have not run a scenario for 90 days, you still need it, right? And if it's been failing 50% of the time in the last 90 days or the last 10 runs, you still need it. I don't know, you have the answer. But at least you need to be aware. And also, yes, you support branching strategies, right? Why? Because you might want experimentation on the branch, and you are not going to have to pollute mainline or trunk or whatever you are calling it with things that are not stable, right? We know those flaky test cases and what they do. The goal of your testware management library is to transform scatter script into an evolvable corpus. You want a library that you can carry again with you. Again, moving faster. DSLs, great book by Martin Fowler that can explain a lot better what this is, but essentially it's going to be your human readable contract between your intent and the framework machinery, how you are doing things. The purpose is to let testers describe what to verify in stable vocabulary, while framework decides how to enact those steps. This is where LLMs might come or might not come into place. I chose kind of on purpose not to talk about it because everyone will be doing AI, so I chose kind of not to. But quickly, this is what we would call an imperative script. So here we're getting very specific commands on what we are doing. Have we seen some of these, even using AI? I think so, right? But the idea is, hey, my CSS selector will change, then my test will break, right? While in this one, which is a kind of a random thing that I came up with very quickly and might not make full of sense, we don't see nothing too concrete, but we still can understand that it's the same scenario. I have a customer, it's somehow getting a product, and it's going to place an order, and then the order will be confirmed. When you compare both side to side, you can understand this will break, this won't. You will still need to create another layer, but this can be migrated. It will live with you, with your product, and you can even move it from one framework on one tool to another. By the way, LLMs are great at writing code. They also excel at writing this kind of thing if you set the boundary. They're pretty good at that. Sorry, the other way around. Oh, another thing, you are raising abstraction layers. Most people would be willing to read these and understand. Also these, but for some reason, this is hard for some people. I'm not going to read that. I don't understand that well. Yes, okay, whatever. But it's important. Design challenge that come with this, right? It has to be rich enough to express complex scenarios, right? And at the same time, it has to be constrained enough to create a parser simple. Do I think LLMs change these? A little bit, but not so much. You still need that layer that talks, you still need Selenium or whatever it is and these drivers. But yeah, building a parser should be simple. A good idea here is to just use the language that is in there, building your own compiler or parser. It's super fun, a good scenario to do, but probably you're not going to have the time to do it. You can use, classic examples would be Gherkin on Cucumber, JSON, as I just saw. You can bring all these things. But yeah, good heuristic, just mirror your business vocabulary. Guardrails and pitfalls. Avoid arbitrary scripting in your DSL, and this is common. The moment you have slip 500, or there's a user saying, I want to inject Python into your DSL, then things are going to start getting tricky. How do you avoid it? Well, provide expansion points so that private users can expand behavior. And avoid it coupling with a specific technology. At the end of the day, a well-designed DSLs will freeze the intent and will allow your implementation to pivot. right? Resource management layer, and again, sorry, I have to connect things very fast, is a set of services that provisions, isolates, routes, disposes the infrastructure each test case needs. Without this, even the better DSL and orchestrator is, it runs for me. It runs locally, right? I was running when I tested it. OK, that's not good enough. Random considerations, you'll need to think that some infrastructure will be per run, other per test, especially if the scenarios are destructive. This is pretty common. Yeah, this is just what I said, so some will defense. Think about it, think how you are going to do it from the beginning, even if you don't do it today, right? And if you're familiar with the YAGNI terminology, you ain't going to need it. Creating structure and not behavior, but preparing this as a structure for expansion, I don't think it's YAGNI. We can discuss about it anyway. So these guys will create and route your components, so you will need some form of intelligent router that can connect all your distributed cloud infrastructure, wherever that is, or network infrastructure, and then you want to export that metadata. You need to see and you need to be able to find the things you created. You need to understand how it's connected. Because everything is dynamic, your resource management layer needs to own factories and ways to inject the data that you need, right? So it's going to inject customers, products, whatever your test cases are going to need. It's owned by this guy. And then when a test case finishes, you are going to use the same things to remove. And it's expensive. Elastic infrastructure is super good, but it's expensive. It can melt your budget. So how are we going to avoid the problem? Well, create alarms, right? The guys were talking earlier about the cost and using IAM roles to prevent it. That's cool. Also add your alarms, right? And then you're going to know that you are getting out of board. And include observability hooks. You don't want, because resource management is dynamic, right? You need to understand when things are happening and what is the current state, right? So emit these events and track it. I'm really running out of time. The way I think about it is it's a mini platform as a service, but dedicated for testing. It's very doable. It's expensive. I think it's worth it, right? Because eventually you are going to end up saving costs at a different point. Reporting. This is how you translate your low-level details into layer visualizations, right? And the way I think about it is in 3 different layers, one on top of the other. At the bottom, I have the task logs and the artifacts. Then I have aggregated dashboards and then business KPIs. So task logs and artifacts is where your granular evidence is going to be. So you have things like request response pairs, the screenshots that you took, your trace spans, and your service stats, right? This belongs to the engineer debugging a specific failure. This is like your lowest level. And then it needs to be, consider searchable indexes if you can. How are you going to find very quickly what happened? And then retention policies, right? Like you don't want to store these guys forever. Why? Right, so try to balance your forensic. And if nobody looked at a test case after 10 days, and the result and it's failing, probably they're not going to look into that. And also compliance. Compliance is important. On top of that, you have the aggregated testing data. This kind of goes against a test suite or an execution. You're going to have pace-fail counts, latencies, error taxonomy if you can identify it. And it provides an overview about a specific run, integrated with your continuous integration flows, whatever those are, your pipelines. Like that's the level you want to add in there. And then if you can automate in that report, builds, feature flags, code changes, whatever was in there. Why? Because it's going to make your life a lot easier. Something that is missing from this slide that I was thinking also about is if you can have the trends, like seeing how a test case evolved over time, super cool to have it there, very useful. And at the top of that, right, managers and anyone with an M on their title usually, or executive, whatever you call them, wherever you are, usually don't care about test case 42 fail. Doesn't mean anything to them. So you need a layer that translates these into customer risk. What does it mean and how is it going to affect my customers? Things like SLAs, the end percentage. Every test case is passing, but you know what? Everything is taking 2 minutes more. Yeah, probably not. Feed this into your release criteria, right? So that it should be easier to understand from this report when to release and when not, and essentially should help the stakeholders make the go, no-go decision. And then avoid low-level details as much as you can. There's the presentation layer as well. Try to get someone that understands and appreciates UX. For me, this is probably the hardest part, or anything else. And here, every widget should answer 3 questions. What failed? Why did it fail? And what do I do next? Right? I'm looking at that. It failed. What now? Right? So yeah, and resist excessive ornamentation here. Black, 5 levels gradients, amazing, right? Looks fantastic, but it's hard to read. Keep accessibility things in mind, internationalized or localized, numeric formats, date format. Everyone in the team should be reading the same story, irrelevant of who they are or where they are. Can we make it? I think so. Orchestrator is the central platform, so you are going to manage and coordinate interactions of the different components. So if your DSL is your sheet music, right, then your resource management is like the guy bringing all the instrument. Your orchestrator is the conductor. He's the guy saying, hey, now it's your turn, go, right, run. You want to avoid, here's where you want to avoid your monolith, and unfortunately, distributed monoliths exist. You can still have a monolith on the cloud, unfortunately, right? So to avoid this, the way I think about it is it needs to be pluggable. Can people call me, or so can I get clients calling me? And then can this be easily extensible, and is it resilient to failure? That's kind of the way I try to avoid that if I can. The first task is dependency resolution, right? Your guy will go, call the Testware management, get the data, spins up the environment, and then register traces IDs for observability. This is super important. You want to understand what your test case did and where it is in your platform. When you see the failure, when you see a log, you need to know that it came from which test case, right? The way I think about it is as a state machine, right? Sequences are important. You prepare, you execute, you collect, you clean up, you report, and you are done, right? Emit events if you can. So SNS was the technology the guys were talking earlier. This is the kind of thing I like because I'm in Amazon. And besides that, SNS is pretty cool. So just emit events, right? Again, maybe they're going to be useful, maybe not. But then the events are there, and you start connecting things based on what has happened, right? This is what I wrote in there. Drivers are the technology specifics. Here's where you are going to be mapping, right? The DSL is agnostic. Here's where you are going to be injecting that runtime. Why? Because today you are doing Selenium. Then you want to move to Playwright. Or suddenly, right, things are going to change really, really fast. So perform primary action. Today is primary button click. And I live through this scenario. Tomorrow is going to be voice say, right? Voice I say primary action. So the way I think about it is as a strategy pattern, but applied kind of to this binding, right? They fail, test cases fail, genuine bugs, flaky networks, misprovision environment, flaky dependencies. Classify them, right? And make sure you don't retry silently. Understand these classifications, right? And try to figure out what to do with them. If the problem was that a database was not there, maybe it was a setup problem and you can retry. But if it was a business assertion, think about it twice or make very clearly, hey, this was not working and it worked the second time. Do I have a bug or not? So make this retry metadata flow into the reported. And then quickly, any software should probably be this. Try to make it stateless as much as you can. Keep your services behind load balancer. Again, not Yagni. And we have only running 100 test cases today, right? Maybe tomorrow you are successful, and then you need to run 10,000, right? And they need to run fast. So add those load balancers if you can. Push checkpoints, or at least think about how you're going to add them. Push checkpoints to durable storage so that when your guard clash, you can restart. And then, again, prepare for horizontal auto-scaling capacity, right? What are you going to do tomorrow when suddenly the guy says, you know what, now we are launching a new country, and you need to go and test everything in there. So Orchestrator, easy to extend. How do we achieve it? The way I think about it is plugin interfaces. Think about them from the beginning, right? And if you build that pluggable interface, right, you can start building your features as plugins. And you know what? Because of that, everyone else can do the same thing. It will hold secrets, be aware of them, protect them. Security is important. Integrate with your corporate vault if you can. Never pass secrets to the command line. I've seen this a lot, right? And generate audit logs, because your security teams might want to come here and understand who called what. So if your company does have a security compliance process, run your automation service through that. Why? Because tomorrow you are going to be testing this super highly classified thing that nobody can read. Well, you know what? Your framework actually has the access. Or at least should get the access. Dog food your own philosophy. Have good state machine transitions documentation and structured logs. You don't want your on-call engineers to be at 2 a.m. spending 5 hours understanding why a test case is not working. Almost done. System under test. And why I added here, and this is the latest thing that I've added, is because it must expose testability hooks if you want your test cases to scale, right? Black box testing forces you to do very weird stuff like reverse engineering. So you are going to reverse engineer logs. You are going to reverse engineer UI. And maybe today is faster because of LLMs, but still, a lot better. White box collaboration. Discuss with your engineers, build those testability hooks in, or observability hooks in. Three things to think about. Distributed tracing, what I was saying earlier. My test framework needs to inject an ID, and I need to be able to identify how that ID spread across the board and my functionality. Health probes. If each service tells me I'm healthy, my dependencies are healthy, I know that when I'm failing, it's a functional failure, right? It's a bug. It's something that went wrong probably on the code more than on the infra. And then if you can add toggleable faults, like this ability, like I'm going to delay my messages 30 seconds or 2 milliseconds, right? Or I'm going to pretend now the database is down, right? Or the payment service is down. Then I can actually normalize disaster recovery, which is pretty cool. Some final considerations, non-functional metrics for your service. Again, what I was saying earlier, if everything's lower, you want to know. Security and compliance. And then that means that the observability hooks in here still need to adhere to the least privilege access, right? You don't want to be exposing security problems or secrets because you need to test. Build a collaboration contract with your product team. Discuss with them, hey, if you build me this today, my test framework is going to identify issues faster, and I'm going to be able to point my finger exactly at what's wrong, right? Very handy. And then use it on the in the design reviews so that it gets budgeted, right? Then it's not going to be a surprise later. Finally, toolchain integration, right? So if you are building with some form of templates, like if your company spins up new products using something, for example, CDK templates would be the technology for AWS, build that observability hooks in there and the pluggability of your framework in there. Why? Because then it will come for free, right? Reduce the friction, people will have less to complain. At the end of the day, is the bridge, observability is the bridge between what we ask and what actually happened. And this bridge needs to be solid. We are going to be crossing that a lot of time. Yeah, and that was it. So we saw distributed system, precise definition, six-sided framework. And if there's one thought I want you to get home is scalable testing requires a full product. It's not a script, right? If it wants to be scalable. You can start with a script, but how are you going to scale it? So think on tomorrow or Monday or whatever you go back to work from everything that you heard and you were able to keep from this rushed presentation. What thing am I missing that would be super cool to have and will provide huge effort? Add it in there, see how it behaves, and then momentum will hopefully do the rest, and you'll be able to go fast. That was that. Thank you very much for listening to me. Please give me your feedback. I know I spoke fast, and yeah, next year I'll try to convince, well, Milan is not here or anyone, but I'll try to do a full day workshop on this.
Open for questions.
Thank you.
One question.
Sure.
Can you please say again how too fast?
Okay. What I was saying, I know. I got it. I know it was fast. No questions? That was too fast and nobody understood anything? Or I was super clear?
Well, the question is about automation. What is to be automated and what is not to be automated?
Great question. I wish once I figured that one out, I'm going to let you know. No, I guess it depends on the business, right? It really depends on different categories. I work in things that are heavily compliant, or you need heavy compliance controls in there, so there's some critical things, right? And then it's more debatable in other areas, I would say, right? General wisdom there says automate what it's repeatable and what you know the results. And if it's flaky and you're not sure, don't necessarily go there. Make sure you understand the scenario and do it manually first. I would potentially might challenge that. I'm not sure.
Automate all the regression tests?
If you can, right? Like, it really depends. Again, it really depends on the size of your. If it's the most important thing for you to automate today, and if it's stable, and you have a product, then yes, it really depends, right? Happy to talk about it if you want to discuss the case more in detail. Yes.
So you talk about the stability hooks. What is the line between the stability hooks in the product and independence from the product you're testing? Because testing has a certain level of independence. Otherwise, you're repeating the same logic the code is doing, you're not really finding a bug. So what is the line where you divide those two?
Yeah. So it depends a lot of where are you testing, right? Like it's a good question. So I would challenge first that they necessarily need to be independent, but let's see where it's going. So let's see. So you have your pyramid where you have your system test and your unit test, and you should go, right? So when you're doing end-to-end, if you're looking at your client, you probably don't want to interact necessarily with those observability hooks necessarily, or at least you shouldn't be interacting to send commands, right? Like I would challenge that. But when it goes wrong, and if it fails, right? If my UI is failing, why is the product not being added to the cart? The next question is, how do I point my finger on the bleeding injury? And that is very hard to do if you don't have observability hooks, right? Like you need to know, I need to be able to trace that ID. That's what I said, like if you can have an ID that you can trace across your system, you can understand, hey, I should have somehow this ID reflected on my shopping cart. It's not there, right? Where did I lost it? Did I answer your question?
Yeah, most of it. The second part of the question was, so in place I've been where there's common libraries in the product that I can import into the test to actually use them. And one of the things I've done is make sure that libraries are tested independently from the actual framework. And then I have two separate set of testing. You see what we're talking about this morning with AI, right? You have a base, what you call a foundation AI, that is AI.
Small models.
But the second part, the question there is, how do you measure the level of confidence in the library that you're importing?
I mean, you mean in your testing, when you say the library, this is...
Yeah, the part that you put in from the code to actually test all the parts. How do you actually provide the metrics that that's accurate enough to do what you do?
On the system under test, right? Like the pass that you're in from the system. It really, again, it depends on the level of testing that you are doing, right? If you are doing component and you are testing because there was a code change, and that's what you want to do, right? You want your regression to pass, and you want, hopefully, your new test cases that map to the new feature to also be passing, right? I think it relates to that. Like, if you are talking about the world of AI in general, where it gets a little bit more stochastic, right, and a little bit more weird, and again, I'm going to echo Carlos here. We are not entirely sure of what we are doing these days with all these tools. I honestly don't think things are going to change that much in terms of why are we testing, right? And how we test, definitely, right? But at the end of the day, when I want to buy a product, right, the product needs to be there, and I need to be charged, and I want the product to arrive at my home, right?
I would say it's more important to test now.
I agree.
Auto-generated code.
Right.
So like your job is a lot more important.
Yeah.
I agree. When you were talking, in your talk, you were discussing about the ratio, right? And now there's a high chance everyone will become a QAE of sorts, if not just a QAE of sorts. Yeah. That is kind of where my thought is going. It's not very popular, and people in general need to be quite drunk to be able to discuss it openly. But that is where I really think it's going to go, right? We are somehow, so I think we might be, without realizing, in a privileged position by being QAEs as that or very related to the quality field. We might be the lucky ones, maybe. At least we know theoretically why we're doing things on how to do things, right? Maybe not, you are laughing. Maybe you know something I don't, and but we'll need to see. Yeah.
Yes. I have a question on the distributive testing. Like,
Yes.
Like for example, in a system we have multiple microservices, right? Let's suppose those microservices are being developed by different teams,
Yes.
right? And in order for those microservices to communicate, so the teams have to decide on a common contract, right? So there will always be a tendency that those contracts can go out of sync. So especially doing if you have a large distributed system with multiple microservices
Yes.
and multiple contracts in place,
Yes.
how because that's the challenge which we are facing right now, to how to automate that end to end when multiple teams are involved, and they all have to adhere to common contracts. Again, if there are multiple microservices, multiple common contracts have to be adhered to, and there's always a tendency that those contracts can go out of sync as well.
Yeah.
So how do you ensure, is it easy to do automated testing of that system? I find it like very tedious to perform that.
Yeah, I think that this is a great opportunity for a testing framework. That's what when I was saying, like, your framework and code opinions. This is where I was kind of trying to go. If you can reach an agreement, right, and I think it's more like even a business or a political skill at that stage more than technical. But if you can place your framework as the tool, as the mechanism that will prevent those contracts from getting out of sync, and at the same time, new things might come first there, right, or in sync, then I think that's a great way to make it easier, right? Is it easy? No. Can it be done easier? Maybe not, but can you try to do something about it? It's a great, I think it's a great mission, right? I'm going to simplify these for everyone.
In a large organization, and if it's like a like multiple microservices maintained by different teams, sometimes it becomes very difficult to come up at a common ground as well.
I agree.
Because they have, like, different teams have their own sort of ways to look at the things. But in many cases, what happens is when they test their own way, like in the unit testing way, but sometimes when all those microservices come together, they break.
I agree.
Because they are not kind of adhering to the common contract stuff. And then we have to make changes and stuff, making sure everything is good. But yeah, prior to that, like it's like difficult to kind of bake in the contract testing within the unit testing.
Yeah, because it serves different levels, right? There's actually a type of testing called contract testing, where you're just going to guarantee that, hey, A can talk to B. Can you help from the perspective of an Uber framework? So can the guy that does end-to-end testing also check that? And can you create some form of tooling or mechanism that allows that to be tested easily? It's a challenge, right? I don't know your business. I don't know the situation. So But I think that's what we should be aiming to do, right? That's my thought. Not sure how we're doing on time.
Any more questions? We might have a time for one more question.
Have questions?
Okay, so if
No
we
more
don't
questions.
have any other questions, big thanks to Walter for showing us the work.
Thank you. Give me the feedback. I know I went fast, but you can say it again.